Assalamualaikum warahmatullahi wabarakatuh. Firstly, I want to introduce myself. My name is Muhammad Uzai bin Yusuf Sabri, and my matrix number is B091810042. Today, I'm going to present about PSM1. My topic is about study on the thermal behavior and cooling performance of nanofluid cool in heat exchanger. Firstly, I want to go on my first slide. It's about introduction. What are nanofluid? Nanofluid is the base fluid combining with nanoparticle. As you can see, the base fluid is water, ethylene, ethylene glycol oils, and acetone. And nanofluid particle, we have many nanofluid particle. Which one is where the metal one is the Cu, Ag, Ni, and Au. And the metal oxide for the nanoparticle is CuO, TiO2, Fe203, O3, SiO2, and zinc O, Fe3O4, and ZrO2, and Al2O3. And for the carbon material is CNTS and diamond. And for the metal nitrides is Bn and AIN. For the metal carbide is SiC. So next we go to what is microchannel heat sink. The microchannel heat sink is usually made from high thermal conductivity material with the high surface area to have high heat transfer with lower temperature difference. Microchannel fabricate to have a high surface area by micro machining technology. As you can see, this is the shape of the microchannel heatsink, where this is the flow direction, and for the coolant flow, this is the base plate for the microchannel heatsink, and this is the fin, and this is where the heat source, uh, where the microchannel absorb the heat. My next slide is about problem statement. My problem statement is to prove that the combining of nanofluid with water could enhance the temperature difference of microchannel heat sink with the various value of nanoparticle compared to pure water cool using in microchannel heat sink. My next slide is about objective. My objective is to study temperature distribution in microchannel heatsink using different type of nanofluid. My second objective is to perform an experiment related between temperature distribution in test rig by using various type of nanofluid. And my last objective is to analyze the effect in the temperature distribution using different type of nanofluid on the experiment test rig. The next slide is about the scope. So my scope is this study will be using an experimental setup such as test rig to study on the behavior of nanofluid towards the temperature distribution effect. In addition, this study wanted to analyze and compare the effect of different type and behavior of nanofluid towards the temperature distribution. So this is my literature review for my project, where Naraki et al. At 2003 study of overall heat transfer coefficient of CuO plus water nanofluid in car radiator. They said perform experimentation to investigate the overall heat transfer coefficient of CuO plus water nanofluid under laminar flow regime. Sodium dodecyl sulfonate was used as surfactant to obtain stable nanofluid. The solution with 0.2 weightage percentage sufficient and pH of 10.1 show higher stability within all prepared solution. As fluid inlet temperature was increased, the overall heat transfer coefficient decreased due to decline in specific heat of fluid. So this is my second literature review, which is Chavan and Peace, 2014. Performance investigation of an automotive car radiator operated with nanofluid as a coolant. So they said made a comparison made between the performance of alumina nanofluid and water as a coolant. Results show nanofluid to better heat transfer medium. Next, I want to go through on my methodology flow. So as you can see, this is my methodology flow, which is the first one. We go on the literature review. After that, we go to the material selection, and after the material selection, we do the experiment setup for our project, and lastly, we do the expected outcome for our project. So about the next slide is about the materials selection for our project. So the material that we choose for the working base fluid and nanofluid are water, which is AI203, Ti02, and CuO. The parameter that we'll discuss for choosing the material is the heat transfer coefficient at nanofluid concentration of comparison with the base fluid. Next, I want to explain about the experimental setup for our project. So as you can see, this is experimental setup for schematic diagram for our project. So the component that we use to experiment to set up the experiment is firstly his heater, and with 300 watt AC power, and secondly heat exchanger. We use the air water compact hex, and thirdly the component for the thermocouple K type for measure the temperature. And next is about pressure transmitter. We use 4 to 20 MA output signal, and the brand is Dyer series 6 to 9. And for the pump is mini submersible DC 12 volt water pump. So this pump can be submersibly. And the next is we using the component flow meter. So this is my expected outcome for the project. So the expected outcome for this study is based on previous research, where the rise in temperature difference show improvement in thermal conductivity due to increase in Brownian motion of particles. The augmentation in volume concentration of nanoparticle cause increase in the thermal conductivity, viscosity, and density, while a decrease in specific heat of nanofluid. This decrease in specific heat of nanofluid can be attributed to lower specific heat of the added particle as compared to base fluid. This has been researched by Sajid and Ali in 2019. That's all for me. Thank you.